Today I want to try something completely new. It's not a tutorial, it's not a crash course, it's not even a yapping opinion video. It's going to be a little bit like a live stream, except for the fact it's not live, I don't have chat or anything. It's going to be me trying to learn something, and if you want, you can watch or not. So I guess this is going to be a couple of hours, 1, 2, 3, 4 hours. I don't know how long I'm going to do this. I also don't know if I'm going to cut multiple sessions together maybe. But the idea is I want to learn assembly, at least a little bit. I want to familiarize myself with very low-level programming, mainly as a hobby, maybe out of curiosity. Of course, it's going to have positive effects on me as a programmer, but I would like to dive deeper into low-level programming, which means assembly, later on also C, C++, maybe Rust, and of course I do have some surface level understanding. I have built stuff in C, I have played around with C++, but I would not consider myself good by any definition when it comes to low-level programming. So I want to familiarize myself with it, and my idea was, while I do that, why not just keep the camera running? Why not just talk a little bit while I'm doing that? And maybe you guys like it, maybe not. If you don't like it, probably I'm not going to do it again. If you like it, if you just like watching me struggle, trying to understand, Google, ask language models and so on, this is not a challenge. This is just me learning stuff. And if you like it, if you like this format, I can do it more often. And if you guys like it a lot, maybe I'm even going to turn it into a live stream format. But that is the general idea, so let us get right into it. Alright, so we're going to tackle assembly today. And as I said, I'm going to treat this like a stream, so there's not going to be any cutting, except for maybe, I don't know, if I need to cough or something, because as always I'm a little bit cold, or at least I have some issues with my voice, so maybe I'm gonna cut out something like this. But besides that, I don't really plan on editing too much here. It's gonna be a little bit like a live stream, except for I'm not live, and I'm going to try to understand something about assembly, try to build something in assembly, and let's see how it goes, how far I get. So the only thing I have here is I have a directory which is called learning inside of my programming directory, and in here I have nothing. I'm going to create now a directory called assembly. And I don't really have a goal for today. I don't really have anything I want to build, anything I want to learn per se. I just want to play around with assembly and see if I can get to a point where I understand the language good enough to build some basic stuff without looking up anything. That is like my goal today. So I do have some knowledge of assembly. So if I go to, let's go back to documents, learning, actually programming, learning, assembly. I do know how to do some basic stuff. For example, if I create now, I'm not sure if Hello World is probably, actually I can do Hello World. So I think Hello World should be something I am familiar with to some degree. I know that when you start with assembly, you have to specify some sections. So I think you say something like section text for your executable stuff. You also have something like section data for stuff that is already allocated, or that you know how much you need to allocate for it. So I think, for example, in section data, I'm not sure, do I need to use colons? I don't know the syntax. I think like this, no. Or is it dot section data? Not actually sure. Let's Google that. So assembly, syntax, data, text. Yeah, section text, and then you do the global stuff. Okay, so basically you have section text. In section text, you specify that you want to have some entry point underscore start. This is a convention, you need to use the name. And then you define your start. And in here, basically for a hello world, you need to first define some data. And you need to then do a syscall to write. You write to standard output, and then you exit, basically. That's what I know about assembly. I know how to move stuff, I know how to add stuff, I know how to do a syscall, and I know that there's a page where you can see all the syscall codes. Assembly Linux. I think it's this one. Yeah, so basically 1 is write, I think 60 is exit, and that's about it. That's my knowledge level of assembly. So I think I should be able to do a basic hello world on my own. I'm not sure how the data was defined. I think it was something like you define message, and then you specify the data type, which is something like DQ. Was it like, not sure what the data type was, but I think you do message, DQ, and then you just specify. I'm sure this is not correct, but basically I do it like this. And then I think I just have to move stuff into registers. So if you look at the table, I think it was I have to write. So I basically move into the RAX register, the code 1. So I move into that 1. Then I move into RDI what I want to print or where I want to print to or write to, which is the file descriptor, which 1 is std out. So like this, and then I have the buffer, which is what I try to print. I'm not sure if this is going to be enough if I just do it like this. So if I basically say RSI and then message, I don't think that will work. But basically that's it. Then I also need the message length. This is another thing. There was some operation that you can do to do it dynamically. I can also just do it manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So not sure. Does it work like this? Let's see. And then I think I just do a syscall, and then I can do also 60 return code 0 syscall. I'm sure this is not correct, but I think this is roughly what a hello world looks like in assembly. I also did a video on this, I already forgot. But now to compile this, or to assemble this, I have to say NASM format is ELF64, and then basically I just specify my hello world. Oh, this results now in an object file, and now I say linker hello world O -o hello world. Maybe it works. Let's see. Okay, it doesn't work. So what is the problem? What is the problem? I think it has to do something with my, it has something to do with my data section. So oh, actually, I forgot to pass the message length. Maybe that's the problem. Oh, there you go. But it prints more than what it should print. So I get hello world, but it prints something else too, which I don't understand why. Assembly data types, or let's say NASM assembly. Yeah, there you go. So you have dB, dq, which is double precision float. Okay, this is actually a float. Maybe I want to call this dB, I'm not sure. And for that, maybe let's try dB. Okay, no, I get something. It looks a little bit like a buffer overflow because I'm printing stuff that I'm not really trying to print. I'm not sure if it's the length, if there's an issue with the length. So maybe if I go with something like 5, if that's going to be different. No, not really. Okay, so it seems to work to a pretty large degree. I'm not sure what the problem is. So let's recap. We have section data, we have hello world, which is a message, dB, just a byte, 3 bytes in succession, string constants, character constants. So dB hello is okay. That should be fine. And it also works, so that should be fine. I think that this message length is a problem. So let's see, assembly get length of string. This was the thing I was talking about. Length of our string. This is actually hello world. But this is the question. Where's the answer? Okay, so this is not a keyword, this is the name. So I think if I use this with message length, it should work. So if I say $-MSG, should this work? Instruction expected. Oh. Okay. Nice. This works. And I think, not sure, I don't think that you can do \n in assembly. But maybe it works. Yeah, so that's basically my knowledge level. Everything else now is, no, okay, this doesn't work. So how do you add to this a line break? Now, what's the ASCII code for new line? 10. So if I somehow get 10, but then again, okay, so basically I would have to do message length plus 1, I guess, and then add a character somehow. So maybe, I'm not sure if I can do that in this section, because there's also another section, this is also something I know. There is this BSS section, or BSS, I'm not sure, where you can define stuff that is dynamically allocated. At least I think so. Or at least you can allocate, or you can define something that you don't allocate yet, or something like this. And in here you can specify buffers, and then you can point to them, and you can choose different bytes that you want to edit. But I'm not sure. Actually, let me briefly open up a second browser. So I can go to my language models. And then we can chat a little bit with GPT. There you go. Of course, we're not going to use GPT-5. We're going to use 404 Mini. So I would like to ask a couple of questions. First of all, let me remove that. I want to copy all of this. And I want to say, explain to me how this message length thing works. The pseudo instruction defines a constant message length equal to the number of bytes between the label message and the current assembly location. The current assembly location. The location counter denoted by $ advances as you emit bytes. Right after db hello world $ points to the byte immediately after the final character. Okay, this is interesting. So $ points to location after defined bytes. So if I get this right, this would mean, okay, got it. So it calculates difference between current location and message, which means, just so I get this correctly, if I have here message 2 with a bunch of A's, that would result in a different number, if I get this correctly. Not sure if I'm going to see any problems because of that. Yeah, there you go. Okay, got it. So if I would want to do something like this, I would have to also subtract message 2, if that is possible. What did I not understand now? We get the current location minus message 2, so I should be here. Okay, then I would probably want to ask, so when I do this, why do I see some A's in the output? Because, in my opinion, if I have... this is the wrong browser. Let me go with this one. If I have... let me change the styling a bit to fit my channel. Or let's go with 111. So, in my world, if I have... Okay, maybe I'm doing it too complicated here. This is not the... Let's use the pen here. Let's go with white. So if I have a bunch of characters, then in my opinion, if I have hello followed by a bunch of A's, then dollar should be pointing to this position. So if I subtract from dollar the starting position here, so let's say this is 0, 1, 2, 3, 4. I'm not sure if this is how it works, but shouldn't I basically go back here? Oh no, wait a second. This is a, yeah, okay. I don't even need the LLM to tell me, because I'm not interested into going to a position. What I'm trying to do is I'm trying to figure out the length, which means I would actually just have to do this, right? Ah, okay, got it. Yeah, wasn't thinking correctly. Because I'm just interested in how long this is, which means I'm taking this position minus this position. Got it. I guess that LLM will probably have said something similar. Yeah. Cool. So let's do it like this. Let's say this is going to be dollar. And let's just comment this out as this is how we would do it with a second constant. Let's comment this out. Okay. Got it. So how do I get now into this whole thing my backslash and my new line byte? Because I know that the new line byte is 10. So in hex that would be an A. The problem is, where do I put it? Maybe I can just put it. I'm not sure if this works, but maybe I can just put it at the position of the dollar sign. I'm not sure if this works if I'm not doing a calculation. Assembly, put byte at position in memory. Let me ask GPT. in assembly, how can I put a byte at position $ manually? Location counter. I think this is probably not the right way to do it. I mean, probably. Not sure if this works like that. Would this work? No. Byte data exceeds bounds. Constant too long. Okay. I mean, let's just give it a try. I don't think that this will work. But if I just say db 0xa, and then maybe I say message length +1 somehow. Not sure if this works. I mean, at least it assembles. Let's link. Okay, seg fault, nice. One thing that I always wondered is, what is a seg fault actually? I know when it happens, but what is a seg fault? So, segmentation fault or access violation is a failure condition raised by hardware with memory protection notifying an operating system that the software has attempted to access a restricted area of memory. On standard x86 computers, this is a form of general protection fault. The operating system kernel will, in response, usually perform some corrective action. To access a memory location it's not allowed to access. So I guess that you have in your application, if I get this correctly, you have some area, like your program is allowed to use these bytes, however many bytes, and if your program tries to access, because of some calculation, this position here, you get a seg fault. This is at least what I think. I don't know if that's true. But yeah, I mean, why do I... Oh, sorry, I'm not showing this. Why do I get a seg fault when doing db 0xa? Or is it maybe it's also because the +1, because of the +1. So I'm not sure if the problem's actually this or that. So let's try to assemble, link, and run again. Okay, no, this is actually the problem. So let's try to give it the code and ask why it doesn't work. Here I get a seg fault. Why? Oh, okay, this is probably what he said before, something with a no op. Do I need to do a no op first? Will this fix the problem? No, seg fault. Okay. Let's read what it says. You've put a single byte at the very start of your code section. This byte is interpreted as the opcode for... Okay, which must be followed by to tell which okay, this is, I think this is just not the way to do it. Okay, wait a second. So oh, it actually told me how to do that. So why do I put 0xa first? Let me see. What if I just do 0xa afterwards? Okay, this works. So I'm not sure if GPT misunderstood what I'm trying to do, but if I say 0xa first, I think I'm going to get the line break first, and then the hello world. Or am I mistaken? Yeah, that's not what I wanted. So actually it's correct. I say hello world, comma, 0xa. You don't do a plus. Cool. Nice. So let's try something more complicated. What could we try to build? We could try to build a simple calculator. The problem is, and I know that input, handling input from assembly or in assembly, so from standard input, is not easy. Because in C, of course, or in any higher level language than assembly, you can just say, get the input, this is the data type, and go for it. So I haven't coded C for a while, but I think it's like scanf or something. I don't have man on the system. Are you kidding me? I don't have man. I don't have man pages on my Arch installation. What the hell? Are you kidding me? Holy moly. Okay. But basically, no entry for... Do I need to download something? Man pages. Okay, there you go. So, with scanf, you basically just get the input from in C, essentially. And everything is easy to use then. So, oh, actually I closed my terminal. Doesn't matter, scanf C. Then you can see that basically you just get a pointer to n, you pass a pointer to n, or the address of n, and then you store the number there. That's simple. Doesn't work like this in assembly, because in assembly, what you need to do is you get some input. The input is text. So you basically, you get some user input. For example, the user types 10 and then the user types 20 because you asked for 2 inputs. Now this here is a string. This is the text 1, 0. And this is the text 2, 0. Which means that now this has to be taken and converted to the byte representing 10 and the byte representing 20, and then I have to do the addition. So let's see if we can do that. We need to handle standard input. Now, first of all, there is read. This is called 0, read. I can read from stdin into a buffer a certain size. That is not the problem. The problem is, I think, the conversion. So let's go back to documents, programming, learning, assembly. And now, hello, world assembly. Actually, let's start a new one. Let's say addition.assembly. We do again section text, global start. And the idea now is we want to have 2 numbers that we add. Now I think that we need to create a section BSS for the dynamically allocated stuff. So let's say assembly BSS. Now, since I'm using a special profile here for recording, I'm getting everything in German, which is kind of annoying because I don't have a Google account connected here. So assembly BSS section. I want to know what this is, and I want to know it in English if possible. There you go. In computer programming, the block starting symbol is the portion of an object file, executable, or assembly language code that contains statically allocated variables. We need to take a look at what that exactly means. That are declared but have not been assigned a value yet. It is often referred to as the BSS section or segment. Static variable has been allocated statically, meaning its lifetime is the entire run of the program. Okay. In contrast to shorter-lived automatic variables whose storage is stack allocated and deallocated on the call stack, in contrast to dynamically allocated object whose storage is allocated in heap. Okay, that's interesting. So if it's not allocated in stack, not allocated in heap, where is it actually allocated? Let me ask ChatGPT about this. I got this from Wiki. If static variables are not allocated on stack and not on heap, where are they allocated? Static storage area. The data segment. Okay, interesting. Cool. Okay. Good to know. The question is now, do I need to define it here? So I need to have a buffer, and the buffer then loads in whatever the user passes in. So, in computer programming, a static variable so I think we can have one input buffer and parse the input from there and turn it into numbers. So I guess let me see how this is done. If I say assembly define buffer section BSS, there you go. Yes, a buffer is just an array, which in assembly is a sequence of bytes. You have three options for allocating it, exactly like in C: static storage, dynamic storage. Oh, actually malloc, interesting. Like a C local variable. Okay, this is now C code. I think we're gonna go the simple way and use static memory. So it's my buffer colon db. Actually, I know a different syntax, which is something with resb. Okay. Assembly resb syntax. Yeah, this is what I wanted to do. So let's use that to say input buffer resb, and let's just allocate 32 bytes. I think a character is 1 byte, so we have 32 characters. Actually, let's go with 16 because we shouldn't have too much input. Let's just say we have 16 digits per number. And then the question is, of course, do I just work with registers or do I keep them around? Let's try to work with registers. I'm not sure if that's true, if that's reasonable. But I'm going to try to say, store whatever you have from standard input into this buffer, and then we want to turn it into a number, actually, in a register. I'm not sure if that makes sense, though. So maybe let's try something else. Let's say num1 is also going to be... Does it actually make sense? No. I think I can do it like this. Section data. Do I say dot text or text? I forgot already. Dot data. Okay, actually, I'm messing up the syntax already. It's of course section dot data dot bss and dot text. What I want to say is I can do a and then maybe dq. What was dq again? dq is double precision float. Actually, we can go with dd, I think. And yeah, actually this doesn't work if I don't have a default value. So maybe, let's say num1, resb 4 bytes, num2, resb 4 bytes. Not sure if this makes any sense. I'm just thinking an integer usually has 4 bytes. So I can just reserve 4 bytes and then see how I can fill them. And the idea now is I do a syscall to or from standard input, and I save whatever I get into the buffer. So I guess I move into rax 0. I move into RDI 0 for file descriptor for standard input is 0. Then I point to the buffer. I don't know how exactly I do that. So I'm not sure if I just do RSI and then input buffer, or if I have to do somehow some pointing operation to it. And the size is, I guess, 16 bytes. Or whatever I get in the input. I'm not sure how I get this, but I would say it's probably just RDX 16. Don't know if that makes sense. And then I do a syscall. We can see if this works by just trying to return, by just exiting with return code whatever is in input buffer. Oh man, this will not work. This will not work. But let's see. NASM elf64 addition ld addition o addition. I can input something 10, and then how do you get the return code? I think it was something with question mark, dollar question mark, 0. That is not what I wanted. I always get 0. Interesting. So if I specify something else here like 10, I should get 10. Whatever I type in, I should get 10. Yeah. Okay, so it didn't work. Now, I'm not sure if I can do that by using square brackets. I'm not sure what square brackets do in assembly. I just know that I have used them before. So I'm not sure what happens if I do this. Input buffer. I have no idea if this is going to work. Okay. Actually, 49. Why 49? Does it actually change when I input something else? No, it's always 49. I guess that's a pointer or something. Okay, so I will need to look up something because I don't know how to proceed with this. Let's do read syscall NASM. So what does he do here? String 1, string 2, reserving 100 bytes. System call 3. No, this is actually not a syscall, is it? Or it is a syscall. Close. Am I not understanding something? I mean, that's the question. Maybe it's wrong. I mean, if this was actually 0, that would be the same idea that I'm going for, because I think that's just a syscall. Syswrite. No, I think we're working with different codes here. Maybe this is 32 bits. Okay, let's maybe use our body here. And let's remove that. Why does my input not affect the return code? So, sysread, standard input, 16 bytes, sysexit. You're telling Linux to exit with the value in RDI, but you haven't actually converted your text input into a number. Instead, you're loading the address. Okay. How to fix it? Okay, this is already the parsing that I want to do manually, so I'm not going to look into that too much. But yeah, okay, maybe we need to do the parsing. I'm not sure. So the idea is, let's just assume that I have the correct number in the buffer now. So I have the text, let's say here now, or after the syscall. Let's assume we have the string not 16. Let's say the user inputs 20 in input buffer. Then we need to there's a difference between the byte 0x1 and the string or the character 1, because the ASCII code of 1 is 49. At least I think so. Okay, seems to be loading too long, but here we have 49 being equal to 1. However, for calculations, we want to have the actual bytes, not treating them as characters. So, assume we have that in there. There is a way to access the least important bit. So my idea is, let's say I have 20. What would 20 be? If I look at the ASCII table, 20 would be 0 and 2. So we would have actually 50 and 48. So I guess we have the byte 50, 48. 4, 2, and 0. So what I'm thinking is that in my input buffer, if I did everything correctly, let's say I would have 0x0, or I would have a bunch of zeros. So I have 16 bytes. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 zeros. Then I would have something representing 50. So in hex, I don't know. Yeah, would be 32 plus 16. That would be, yeah, I don't want to do the conversion right now, but basically you have this if you express it in decimal. So if you express it in decimal, that's what you have. The question is now, how do I do the calculations? So let's say I have another buffer. Or actually, no, I don't have the buffer. But theoretically, let's say I would have an input buffer too. With the same idea, just that the number is 10. Then I would have this. Now, of course, the addition like this doesn't make a lot of sense. So actually what I want to do is I want to turn this into just 20 and this into 10. So let's say this is input buffer 2. So my goal here should be to take input buffer and to do some parsing so that in num1 I get 20. And then I get the new one, and then I get num2 is equal to 10. That is the idea. Now, how do I do that? I think I have done something approximating this before, where you basically divide by 10 and you take the remainder. However, dividing in assembly is not straightforward either, because you basically have some convention where you, when you call diff, I think that's the keyword for division, you need to know where the result ends up and what you're actually dividing. So we're going to have to look this up. But just conceptually, the idea is if I... No, actually, what I would like to do is I would like to take the input buffer and subtract 48 from each position. Because then my input buffer would be all the zeros. I mean, if the 0 is 0, we just keep it at 0. But for the other values, then I would have 2 and 1. And if I have 2 and 1, then I can go to the least significant bit, or byte in this case, 1. And I could say that that is just to be added. So in this case, add 1 to number 1. No, actually, sorry. That would be 0. Okay, we already have the number in there. So all we would have to do is we would have to... What do we have to do? We would have to do some additions. We would have to say, okay, 0 out num1. Make sure it's full of zeros. And then say add to num1. 0 times 1. And then add to num1. 2 times 10. Not sure if this is intelligent. I'm not going to proceed. I'm not going to go down the rabbit hole for too long. I would just like to see if this works at all. So we assume again, and this is not necessarily true, that I have a solid string like this, that the bytes are arranged like this in the buffer, that I have a bunch of zeros, and then I have 50 and 48, which I don't think has to be the case necessarily, but let's just assume that's the case. Then I would like to subtract from each byte. So let me ask assembly, let me ask ChatGPT here. In NASM I'm always saying NASM because I want to have the correct syntax here. In NASM, let's say I allocate 16 bytes with res_b in BSS. How can I subtract a certain value from each byte? Oh, I need to use a loop. Oh boy. So, this means I have a counter register and an address pointer. So I think this, I forgot what this stands for. I think it was something like something with address. Load effective address. Got it. So basically I'm loading into the register RDI the address of the buffer. Rel. Is this the relative address? Not sure. And then I just... Okay, boy. This is complicated. But let's say, okay, I move into RCX 16. And then I point with the lee instruction. In RDI, I point to rel input buffer, whatever rel means. Points to the first byte of buffer. And then I just subtract in the loop. So I have a waypoint or a marker or whatever you call this. Loop. And in here I say subtract the byte. We need to specify the byte. I'm going to have to understand why this is the case. But we subtract from this 5. Now I don't want to subtract 5. I want to subtract 48. However, and this is now the tricky thing, if it's 0, I don't want to do that. So I also need to make a check, because you cannot just say, there is an assembly, you cannot just say min or if or something like this. You have to basically look at the byte, compare it to 0, and if it's 0, you just jump out of the loop. So actually, I would like to point to the last byte and go back. And if I encounter 0, I stop. Provided that the fields are zeroed out. So I have a bunch of questions here, but one thing I would like to adjust here is how can I do this from right to left instead? Plus 15. Or actually plus 16 if we decrement first. Okay, this is super complicated to just parse some input. But this is what happens. Now, if you see that, you can really appreciate how simple C is. And let alone Python, of course. But this is crazy stuff you need to do just to parse a number. This is just parsing a number from standard input. Yeah. So we would have input buffer plus, let's do 16. I want to start. So basically what we're doing now is, if I understand this correctly, we have 16. Let's just say we have 4, but imagine this is 16. This is our buffer. And now I'm pointing here to the next address. So what I would want to do is I want to decrement this pointer So it points to this here. Then I want to say if not 0, I have some voice cracks today, sorry about that. If not 0, subtract 48. Else, stop. So I guess how I would like to do that is I would like to have this pointer here. I would like to have the counter. And then in the loop, I would say, I think there's a test instruction where you can do an AND. I'm not sure if this is how it works, but I think if you do test RDI, RDI, that will load into a so-called, I know a little bit about assembly. There is a thing called zero flag, ZF, which is a little bit confusing because what happens, as far as I understand it, is when you test RDI, RDI, you're basically saying RDI and RDI, which means, in clear text, if RDI is 0, this is true. Which means, if RDI is 0, the 0 flag is going to be set to 1. And now there is a command or an instruction called jump if not 0, J and Z, in assembly. And J and Z jumps if not 0, but this means if 0 flag is 1. So it jumps not if 0 flag is 0. No, actually, sorry, other way around. It jumps, this is always confusing to me, because the 0 flag is not what we're looking at. If RDI is not 0, we jump. So, RDI is not 0 if the 0 flag is 0. Because if RDI is not 0, that's going to be false. The 0 flag is going to be set to 0, which means that we jump if the 0 flag is in fact 0. This is how I understand it. Basically, that means first of all, of course, I have to decrement RDI. So -1. Then I'm looking at this here. So let's say this is our 48, our 50, and we have 0, 0. So what I want to do now is I want to see if it is. But this is a bit confusing because I don't know where to jump to if it's 0. I cannot just break. This is not a loop. We don't have loops in assembly. You cannot just say if break. So how do you do that? So if it's non-zero, actually, we could try to assume that there's always going to be something in here, because otherwise it's invalid anyways. So for the first one, I don't even have to check. So I can just do the subtraction. Which, how did we do that? Let me get ChatGPT back here. Byte RDI. So that would be sub byte at the current position that we're pointing to right now. Subtract from this 48. Then, actually no, let's do it like this. 15 sub decrement RDI test RDI If RDI is not 0, jump to loop. This should work, right? Not sure. The idea is you start already, now we have a different concept. Now we don't start here, we start here immediately at the last byte. We just perform blindly the subtraction to keep it simple. And then I decrement and go here. And I say, okay, if this is 0, then, or if this is not 0, then repeat. So subtract 48, decrement. Now it's 0, so I'm not going to jump, so we proceed with the rest of the code. That is the idea. So if I'm not mistaken now, at the end of this, actually we can already do the addition as well. Oh boy, there's a lot of things that I need to consider now, because we need a bunch of counters. We need the counter. Maybe if I do move RBX. How do I do multiplication in assembly? Because my idea was I can start with 1 and then I can always multiply. But I'm not sure if I can do multiplication in assembly. Mul operation. Okay, I think it's easier to work with ChatGPT on this one. How do I multiply in NASM? Unsigned multiply or signed multiply. We don't care for now. No, we don't care about signs at all, because we're just using 10 to the power of something. So first operand, second operand, you load into RAX and RBX, which means I cannot use this, or actually I can use this. Am I using RAX for something? No, only for the syscalls. So we can go and say, I can just keep. The result ends up in RDX, okay. And RAX. Now actually RDX can be 0. I'm not sure if we need to do it manually. But in my world, in my idea, I start with 1. I have 10 in RBX. If I have RAX, RBX, then if I call mul, if I understand this correctly, I say mul RBX, the result is going to be in RAX. If it's too long, it's going to go to RDX, but basically, for all intents and purposes, it's going to be in RAX, which means, I think I'm overcomplicating this, but I don't know. I have a number at the end of this. So I subtract 48 before I decrement the pointer here. I am pointing now to some digit, to some byte value that's the actual number. So if my input was 23, I'm now pointing to 0x3, the byte with a value 3. So I would just have to say, take what's in RAX, the problem here is again, how do I do that with the powers of 10? Because I need to multiply and then I need to add. But how do I know how many times do I have to multiply with 10? I think there's probably an easier way to do that. Let's maybe look if I can find a simple example and get inspired by it. So assembly, parse standard input number. XOR is used to set stuff to 0. I know that. This is just the input stuff. Now here is C. Okay, this is of course not what I'm looking for. So let me ask my friend here. In NASM, how do I get a number from stdin and parse it so it is as the actual number, not the character bytecodes in a register? Give me the simplest code example. Okay, so that's buffer, does the standard input syscall. Then we zero out RCX. We point to the current character, which is now, what does this point to though? Does this point to the last byte or to the first byte? Anyways, what it does here is it loads the byte that we're pointing to. It compares it with 0. What is JB? NASM JB. The signed flag. And jump if signed, okay. Or actually, this is the question. Maybe it's not true. So we had somewhere here the NASM JB instruction. Carry flag. Jump if below. Oh, actually it says it here. If less than 0 must be a new line or non-digit. Done. So we jump to done. Compare with 9. If it's above 9, we also jump to done. Otherwise, we subtract the value 48, which is character 0. We do a signed multiply. Why is that? Times equals 10. What is RCX again? It's 0. Not sure I understand completely. Let me just close this and open up a new one. Just to have a fresh start. So let's just start with the parsing. Let's just try to do basically what we get here from ChatGPT. We do the same global start. We had our section BSS, which was our input buffer, which was reserving 16 bytes. And then we start again. We do the syscall. This is also still the same. We move into REX0. We move into RDI0. We move into RSI, the buffer. So our input buffer. And we move into RDX60. And then we do a syscall. Okay. So, it zeroes out the RCX register, which is the result. Okay. It moves the current character. I don't know what the current character is, but fine. What I don't understand quite, I think, is... I understand this part. This is quite trivial. We load the byte. We check that it's in the range that we're interested in. Then we subtract. That's fine. What do we do here? So, if I turn this into something visual, let's say again I have... let's say again I have 4... Can I somehow get rid of this? Yeah. Let's say I have 4 bytes. Now let's assume that current byte... No, actually, okay, it's increment. So actually it starts here. So if I have 1, 2, 3, 4 as a number... No, actually that can't be the case. Maybe before I just trust it, let me see if that actually works. Because otherwise it's going to be addition GPT ASM. Otherwise I'm going to be pretty pissed. Oh, sorry. Okay, maybe there's some overflow issue. So it's going to be a bit loud now. This is my microphone stand. It's not well oiled, let's say. Okay, so it seems to work to some degree. Yeah, okay. At least it works somehow. So... read from SD in, and then it points to... it loads the byte. So, current char. What does current char mean here? Last one or first one? It's the first byte you read into the buffer. Okay, but in the beginning, if I pass 1, 2, 3, 4, is it 1 or 4? Okay, so it goes from left to right. I don't quite get this though, because in my... maybe I don't understand how this is organized in memory, but in my idea of how this works, if I have 8 bytes, and I have 1, 2, 3, 4, then in my opinion, it looks like this. So, like, not even these are not the characters 0, these are, let's say, empty bytes. And then I have 1, 2, 3, 4. So if I start here, and this is again not the character, these are the characters, and this is not a character, then in my opinion, what would happen is I would load the first byte, I would see that it's, let's say, below 0, and I would jump to done immediately. So I don't understand something, but I don't understand. Let's say I have 8 bytes and I write 1, 2, 3, 4. Would my buffer not look like this? 0, 0, 0, 0, 1, 2, 3, 4. Then if I start at 0, would this program not jump to done immediately? Okay. Interesting. So maybe I didn't understand how this is properly structured in memory. Interesting. So you're pointing to the start of the buffer. The kernel's read system call always writes bytes starting at buffer plus 0. So after typing 1, 2, 3, it's loaded from left to right. Okay, I didn't know that. Interesting. So our memory actually then doesn't look like this. It's first this part, then this part. Got it. Okay, now that we know that, can you understand what's happening? Zeroing out this, pointing at the first position, then we're comparing, works. Okay, then we subtract, and then now for the 1, I would have to multiply it with 1,000. Oh. No. Does this make sense? Let me briefly open up a Python shell to check something. If I have 1, 2, 3, 4, what I would be doing here is I would say the result is empty. So I have nothing in RCX. And I multiply it with 10, which is still 0. Then I add 1 to it. So now I have 1. Next time I multiply with 10, so I have 10, and I add 2, 12. Next time I multiply with 10, and I add 3. Oh, got it. This is how it's doing it. Okay, intelligent. Yeah, makes a lot of sense. Okay, maybe I can do it now. Let me scroll up so I scroll down so I don't see the code. Let me try to do it again myself. So we started by zeroing out a register for the result. So we can do that. We zero out RCX. For those of you who don't know what XOR is, basically if you have some bytes, like let's say we have the bits, something like this, and then something like this. Then XOR would give you the difference. So a 1 word whenever it's different. So that would be 0, that would be 1, that would be 0, 1, 0, 0, 1. Because there's a difference. If you do that now on the same set of bits, so if you have 2 times the same thing, obviously you're going to get 0. That is the idea of XOR. This is why we use it to zero out the RCX register. And then it moved the pointer to the input buffer into a register. Yeah, so I don't know which one it chose. Let's go with RDI. Did it choose RDI or RSI? I want to see that. RSI. I don't think that it really matters. Or actually it does matter because we're going to use that for... No, we're not going to use it for anything. So let's go with RDI. I think it doesn't matter. We're going to point to input buffer. Okay. And now we had the parse loop. And we started by... So now we're pointing to the first position. So we want to take that position. We want to compare it to 48 if it's above or below that. So I'm going to say now, compare the value. Now I'm not sure, do I need to dereference here with these square brackets or can I just say RDI? I forgot already what we did, but I think it's like RDI compared to 48, which is the same as typing 0. So let's just do it with 48 here. 48 is equal to 0. Now let me see if this is how it did it. Yes. No. Actually not. What is the AL register? What is the AL register? Okay, so the AL are the last. It's the last byte of the RAX register. I'm not sure. Low order byte. Yes. And it used that for the comparison. So yeah, we're just loading a single byte, so it doesn't really matter. So we have the individual registers. Now this is shifted for some reason. So I'm loading a single byte. I'm loading a byte into a register. Whatever register I want to use for that. In the code example, it used the 8 register. Now we can just try something different and say BL to see if we understood everything correctly, because that should just be the least important, the low order byte, the last byte of the B register, of the RBX register. And into this now we load the value that we're pointing to with RDI. So RDI is pointing to the first byte of the input buffer. We're loading that first byte into the register B, into the lower byte of the register B. And now we're comparing that to 48. If jump if above that, so if it is above, and then of course we need the waypoint or the marker down here, done. Jump to done. Then I think we did the same thing, just with jump below. Was this correct? Yes. No, actually, sorry. Okay, makes sense. If it's above 9, we jump. Okay, so let's do jump below first, jump above. And for 9, we would have to add 9. So that would be 57, I think. 57 is 9. Jump above, jump to done. And then in all the other cases, we're subtracting 48. So it's subtract from BL 48. Yes. Now we have the value, and now what we do is we multiply with 10. I don't think that we need a signed multiply. I think mul should also work. So we multiply the result. Let's remember, this is the result register. We multiply RCX not sure. Let me just see how the multiplication works in assembly. Mul instruction assembly. Takes 3 values. Okay, so I guess it's operator 1, operator 2, and destination. What I don't understand though in my code here, in the GPT code, it's using the same thing twice. So it's, I guess it's probably first destination and then the operands. So let's say it's RCX. Let's see if I can swap it around, then we can see if that's actually the case. So if that is the destination and these are the two operands, then it should work. Because then it doesn't matter, it's commutative, so 10 times RCX is the same as RCX times 10. And then we're going to add. So we're going to add to RCX BL. Or not. What did we do here? Okay. I'm not sure if this is necessary. Or if I can just do that. If problem, try RBX. It's always good to try to deviate from the code that you're looking at, so to play around with it a little bit. And now we increment RSI to point to the next character, in our case RDI, and then we jump every time to the parse loop. Got it. And now we can just return a syscall. So I think it was RDI. And RDI needs to now, we need to move into RDI now, RCX, and then syscall. NASM, addition, new ASM, error, impossible combination of address sizes. Invalid 16-bit effective address. Probably this is oh no, this is not the problem. Okay, but this did work here. Interesting. Why is that a problem now? I mean, is BL not what I think it is? Because I thought BL is just AL for... Let's see if I change this to A, if I get the same problem. Oh, sorry. One thing that could be causing the problem, I'm not sure if that is the problem, but I didn't specify the format. No, still. Oh, actually now, okay. Line 19 is now fine. 29 and 30 are not fine. 29 multiplication. Okay, this is interesting. What does it say? Invalid combination of opcode and operands. So does this change if I say RCX 10? No, still doesn't work. Why though? Maybe because I'm not using imul. Okay, so there is a difference. Why does imul RCX 10 work, but mul RCX 10 does not? Destination, source. What is im? Okay, I don't know what im is. Okay, so if we do mul, it works with the registers, like diff. So imul is just easier to use. But then again, I don't understand why can I not do imul RCX. or RCX 10 RCX. Oh, that's a constant. Got it. Okay, so let's note this down. Destination, source, constant. And here I guess the problem is just that we're not using RBX because there's an incompatible size. I think that's quite straightforward. LD, addition, new O, addition, new, addition, new. 1, 2, 3, echo, $? There you go. Okay. Cool. So, the idea for me now is, let's just do it super, super simple. Because now, no, actually we cannot do that. So my question now is, how can I write to memory? This is what I wanted to do before, right? Number 1, reserve bytes 4. Number 2, reserve bytes 4. Now the question is, how do I write to a buffer? Let's see. Let's say I have a value in a register like 1, 2, 3 as int. How do I store that into memory? Oh, that is kind of simple. So, if I'm just thinking how I'm going to do this now. So, I think it should be possible to just say here num1, and the result was an RCX, like this. Yes. Okay, so let's see if this works by actually doing... Yeah, this doesn't make a lot of sense. No, actually it does make sense. So let's go with num1 to see if it actually works. Okay, cool. So now we can place our stuff somewhere. Now, I know it's not a beautiful solution. I just want to see what happens when I just copy this here. The entire thing, actually. And I just do it again. So actually, where did I stop now? I stopped here, right? Yeah, so I'm going to copy this. And I'm going to paste it here. I'm just going to call this parse loop 2. Or parse loop second. I'm not sure if numbers are allowed. Done second. Done second. Parse loop second. Done second. The only difference, I'm going to store it in number 2. And then I would like to say move into register RCX number 1 add to RCX, or no, actually I need to say let's say move into RBX number 2, move into RCX number 1, number 2, and then I think I need to say add RBX RCX. And then let's move into RDI, RBX. Not sure if that makes any sense, but I somehow feel like this should be able to do an addition. 1, 2, 3, 1, 2, 3. There you go. Okay, nice. Cool. The question is, how can I do it more elegantly without repeating the code? I just have to change what I'm saving into. So let's get rid of, let's get actually rid of this. Again. Here. No, actually this as well. How could I somehow go back? Maybe I just have a flag that I can set here somewhere. Is there a register I didn't use at all? I don't know. I'm just doing something now. Flag, res B1. If I now say test, or let's say done flag, let's just say flag. And let's say the first thing I want to do here is or actually maybe I can use a data section for this. I'm not sure, can data be manipulated in assembly? Can data change in assembly? Can I change the value of, come on, value of stuff I define in data? Okay, so that's possible. Then I can just set my flag in data. How can I make it a single byte? Where's my page? How can I make it a single byte? Actually, I even just need a single bit for this one. db. Okay, flag db 0. Actually, maybe let's set it to 1 by default. And let's say when I get here, I'm just gonna load this. So I'm gonna load into a register that I'm not using right now. Or actually, sorry, I need to do... No, actually, let me see how I do this. First, second, so we're going to compare, or actually I'm going to load first into, let's say, RAX, doesn't really matter, I think. I load into the RAX register the value of the flag. And then I say test flag, flag. If the flag is not 0, I'm gonna go to first. Does this make sense? The question is, if I don't jump there, yeah, otherwise I'm gonna jump to second. But the problem is I need to somehow set it, so I do that, and then I need to set. So this is where my question comes in. How do I write to that? I can just load into racks something else. So I can say move racks 0, I guess. And then I can say move into flag racks. I don't know if that makes sense. But now I have everything here. And now I should be able to say move into RCX, or RBX is how we did it. Move into RBX number 1. Move into RCX number 2. Add RBX, RCX. Do that. 43. Oh, sorry. One, two, three, 1, 2. Okay. What was the return code? Oh. We need to do another waypoint here. Or maybe, I'm not sure, can I go back to start? Not sure if I can go back to start. That would be cool. Okay, now it goes to start all the time. Why is that? I get here. I get to the end. Done. Jump to first. Not sure if that's a problem with start or if it's a problem with my code, but let's say main loop or something. Let's say jump to main loop. Okay, there's some other problem. Let's go through the logic quickly. I start with standard input. I zero out RCX. I do all the parsing. And at the end, once I'm done with the parsing, I should have in RCX the result. So I'm done. I move into RAX, the flag. I test if the flag is still 1. If the flag is 1, so not 0, I jump to first. So now I say load the result into number 1. Set RAX to 0, set the flag to RAX, and jump back to the main loop. Now everything is again standard input, blah, 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 parsing, jump to done. Load the flag should now be 0. So it should not jump here, it should jump here. Number 2. Actually, this should work. So let me ask ChatGPT, Why do I get into an endless loop here? Oh, I'm loading and testing the wrong size for flag. I defined it as 1 byte, but then I do... Oh, I load it into the register. So probably before I read the rest, let me see. That means since I just have a byte, I should be loading it into AL. Right? Is that correct? Would that solve the problem? Oh. Wow. Okay, 44. 100 and 200 is 44. I want to ask ChatGPT why that's the case. I don't want to troubleshoot this myself now. So first of all, he did the same thing. That's fine. Okay, I don't want to read all this stuff now, but let me ask again. Why does this work sometimes? E.g., when I pass 2 and 123, I get 246, but when I pass 100 and 200, I get 44. Oh, okay, this is just because of the exit codes. So, okay, so the calculation works, but if I want to actually see the correct code, I cannot use the exit code because it wraps around, it seems. Yeah, modulo, yeah, it wraps around. So the problem is not the result. The problem is that I'm using the exit code, so I would have to print. I don't want to go through printing right now. I think that's enough for this session in terms of parsing. So let me just briefly see if I can get this to work with 10 and 20. There you go, works. Let's see, 123. There you go, okay. That's not the problem. Addition works. Now, let's briefly recap what we did here. We have a buffer for the input, 16 bytes. We have number 1, number 2, 4 bytes. We have a flag that is a single byte. That is 1 by default. We have our program section. We start by reading from standard input. We zero out the C register, RCX. We have a pointer to the first position of the buffer from left to right. We move that byte into... Oh, that is also why we use this here. Makes sense. I want to research that, why that is necessary. But we load that byte into the register. We see if it's between 0 and 9. Otherwise, we jump to done. And otherwise, we subtract 48, which is the character 0. Then we do a multiplication. Then we add, then we increment. Once we're done with the parsing though, we get the flag. If it's the first time, it's going to be 1. So then we jump here and we just, save into number 1. We set the flag to 0. Otherwise here we set to number 2 and then we do the addition and that's basically it. So what I would like to know now, I'm going to ask ChatGPT, is in assembly, when I load a single byte, why is it important that I also load it into a register that is a single byte? For example, if I have section data flag db1, why can I not just say move rax flag, but need to say move al flag? This is, by the way, in my opinion, a very good use case of large language models, to let it explain stuff to you. You don't want to use it for coding too much, in my opinion, if you want to keep your brain cells. But when you don't understand something, instead of just Googling sources that may not be compatible with the version, with the architecture that you use, asking ChatGPT, of course, thinking, does it make sense? Sometimes it will hallucinate. But letting ChatGPT explain concepts to you is super awesome. And for those of you, in case you're wondering, because I tweeted that I canceled my subscription, I resubscribed because you can now use O3 again, because 5 is absolute garbage. So you can only move as many bytes as the destination register can hold. Flag is a single byte. If you write, you're telling the assembler load 8 bytes from memory at address. Oh, okay, so that is basically like a, not necessarily a buffer overflow, but you're reading past. So if I understand this correctly, what we're doing is, if I have, let's say these are bytes, not bits. If I have a couple of memory addresses here and I have a byte here, let's say 50 or something, then if I say load this byte into a register of size 8, it will take 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it will take the whole thing and load it into rax, which is also 8 bytes. But if I want to say, okay, store that here, then I would be just saying load it into al. Cool. So finally, before I end this video, I would like to see what I would get from ChatGPT if I ask it to do that itself. So I want to see how it's done professionally. Write NASM code for a simple adder. It should load 2 numbers from std_in, add them, and exit with the result as return code. Let's see how much more elegant this is than what I built. This is not elegant. Okay, this basically does what I did in the beginning with just copying it. So let me see if I can, or actually let me paste my solution. Which solution is more elegant? The one you wrote or this? Okay, so it says its code is more elegant because it doesn't use any memory. I think probably mine could be more readable for humans, but I think this one is more optimized. I have no clue how to code in assembly, so I'm assuming that the solution is going to be better. So let me try something else. Make sure your code is optimal and perfect. No comments. It will take a while, I guess. But I would be interested to see what the optimal solution for that is. Maybe we can also Google and see if someone else. Simple adder assembly. No, not simple calculator. Okay, we got a response here. It uses a flag, but it doesn't use it as a variable. It uses it in a register. Okay, that's also possible, of course. You use registers, that's better. Yeah, actually, of course, we can replace our flag in memory by just a flag in a register, R8, for example. But essentially, here it does a syscall for std_in. It zeroes out a couple of registers. It parses in the same way as before. Does a multiplication. Okay. What does it do here? Okay. I don't want to analyze this now too much. But cool. I think this is a good start for learning assembly. I definitely understand a couple of things now. I understand why you need to load the same size, so the correct size into the buffers, or into the, not the buffers, into the registers, so that you really target where exactly you're saving stuff. I understand why I multiplication works like this, and multiplication does not work like this. I understand how to read and write from and into memory. And maybe if you guys like this, I'm going to do another session like this where we can try to do something else, maybe some more advanced stuff. I think the language definition of assembly is not too comprehensive. I think you can understand assembly in terms of what it's capable of, in terms of the instructions and features very quickly. The question is, how do you do stuff? I don't know if I want to go too deep into that, but what I plan to do actually, or what I would like to do, is I would like to do a couple of these videos where I go into assembly, and once I feel comfortable with that, I would like to create a crash course. So like my usual videos where I do an assembly crash course. Once I understood all the stuff, once I'm able to build some stuff with assembly, I would like to do a crash course where I teach you guys assembly based on how I learned it here. So you can see both sides, how I learned stuff and how I teach stuff. And yeah, I would say, let me know in the comment section if you want to see more videos like this one, more chill, stream-like content, and yeah. I still need to do an outro, so that's it for this video today. I hope you enjoyed it. I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and